Here's another fairly straightforward and easy one, just a couple details to pay attention to. We're still talking about presenting data visually, and here we're going to go for a completely graphical one with some labels, but we're not going to be looking at numbers like we were last time talking about frequency distributions, where we still have to look at how many of each, or in the case of the relative frequency distribution, what percentage of the time we got this result. Here we're going to draw a picture, and the picture is called a histogram. You might also think of it as a bar chart or a bar graph. I think online, I look this up every semester and I can't remember, the distinction between a histogram and a bar graph is stupid. It's like there are spaces between the bars on one of them and no spaces between the bars on the other, but I think that's ridiculous. What we're going to do here, it's going to have a bar to represent each of these, and it's going to be vertical, just because that's the way we do it. We could do it horizontally also. So we're going to have a bar to represent the people with one sibling in their family, the people with two siblings, etc., etc. So we're going to need 1, 2, 3, 4, 5, 6 bars, which means we're going to divide our x-axis up into 6 roughly equal. I didn't do a very good job there. I didn't count my squares, so I'm going to kind of fudge that one a little bit. But each of the bars should be the same width, and we want to label them. There's 1, there's 2, there's 3, there's 5, there's 6, there's 7. And since we're kind of looking at this as categorical data, we really don't need to put the 4 in there. It's not necessary to show that there's no 4s. We could if we wanted to. We don't need to. Now our y-axis, our vertical axis here, is going to represent how many are in each category. We don't care about the percentages here. They would work out the same. The labels would be different, but there's no need. I just wanted to use something we'd seen before from a couple lectures ago. The most represented was 5, so we need to have our y-axis, our vertical axis, go up to 5. And again, we want to have them be all equally represented. We want 1 and 2 to be exactly as far apart as 2 and 3, and 3 and 4, and 4 and 5. Now this does really represent a quantity, so we can't leave anything out here. We're not going to leave the 4 out on this one. And then we just need to draw the bars. Bar number 1 should come up to 3 to show that there were exactly 3 people who had just one sibling in their family, or whatever this stood for. Bar 2 needs to come up to 5 to show that there were 5 people who responded 2. And then there were 2 people that responded 3. And then there were 1 person that responded 5. 3 people responded 6. So up to 3 again there. And then only 1 person that responded 7. I apologize for being left-handed and covering what I'm writing. Can't do much about it at this age. So there's our histogram. And we do have some exact numbers in here, but we can also tell just by looking, boom, 2 was represented way more than the others, with 6 coming in a fairly close second, and we had 5 and 7 straggling behind. That information is all right here, but it's not as immediate and as visual as it is when we do a histogram. Okay, got this color. This is the same data from a couple times ago also. Never added those up. They came up to a total of 27. We have 1, 2, 3, 4, 5 different categories. So 1, 2, 3, 4, 5 different bars. We want to label them. Red, blue, green, yellow first, then orange. And the most represented was a 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our tallest bar is going to go up to 10. So our red bar is going to go up to 8. Our blue bar goes up to 10. Our green bar up to 6. Our yellow bar up to 2. And our orange bar up to 1. Incredibly simple histograms. There's not really anything more to it than this. There is one sort of silly thing I point out occasionally, that is, there's a special kind of graph called a Pareto chart, I think. And I think I have this right, where it's just a histogram with the bars in descending order. So if we were to switch the blue and the red here, so the tallest one was first and it consistently gets shorter, that has a name of its own called a Pareto chart, which really just exists to honor a statistician named Pareto. All the high-level stuff he did was too high level for it to be really honoring him, because then people would never hear it. So they took something simple and put his name on it, but we're not going to worry about that. We're just going to worry about a histogram. And you will lose points if you put spaces between those bars, because that's a bar chart, and that's not what I'm going to ask you for.